Hello everyone, welcome to my channel Euclid Mathematics. And here in my today's video, I'm here with the topic from real analysis. In my today's video, I will explain the previous year question from CSIR net, which is solely depend on continuous function, uniformly convergent function, and that their limit exists or not. Okay. So in my today's video, we see that example fnx. Okay, and we figure it out which one of the option is correct here. Okay. So let's get started our question. So let fnx is given. It is a two values for that function fnx, 1 minus nx, when that x which belongs to close 0, 1 upon n, okay? That x it is here, okay? That small x. And when fnx is value 0 for x belongs to 1 upon n and 1, okay? Then we have to figure it out which one of the option is correct, okay? First option, it says that limit n tends to infinity fnx define a continuous function on close 0, 1, okay? So we have to check whether that function is continuous or not. When we say that it is continuous, when the limit of a endpoint, okay, limit of a endpoint gives a finite value exist and equal. Limit of a endpoint finite value gives finite value exist and equal for 0 and 1 by n. Then we say that it is continuous. If it is not continuous, then not uniformly convergent, okay? So you can use the other test also to check whether it is uniformly convergent or not, okay? Now third option, it says that when we apply limit n tends to infinity to fnx, it gives only 0 value for all x are there from 0 to 1, okay? And option D, it is given here limit n tends to infinity fnx exists for all x belongs to close 0, 1, okay? So you can see it here that close 0, 1 upon n, interval is broken here, okay? 0, 1 upon n and 1 upon n, 1, okay? So actually this is the interval close 0, 1, okay? So when it is broken, it gives two values, okay? Now let's find out which one of the correct option is correct, okay? So first of all, we will work on a continuous function, whether our function is continuous or not, okay? So in my solution, you can see it here. So fnx, it is given here for these two intervals. Okay, now let's check out whether the function is continuous or not, okay? When function is continuous, when we apply limit x tends to 0 and limit n tends to infinity as x0 and x1 by n, okay? So for when x is a 0, if we select x is a 0 for fnx 1 upon nx, then apply limit n tends to infinity fnx and x is a 0, okay? So we can see limit n tends to infinity fnx 1 minus nx, okay? And x I selected here 0, okay? 1 minus n into 0, it is 1. And limit n tends to infinity 1, it is remain 1, okay? Because n into 0 is 0, so 1 remain 1. Okay, now next, when we apply limit, when we apply x is 1 by n as a n tends to infinity, okay? Okay, so you can see that limit n tends to infinity fnx, n tends to infinity, x we need to substitute 1 upon n, okay? So 1 upon n, 1 minus n into 1 upon n, okay? 1 minus 1 is a 0, okay? Limit n tends to infinity, 0 remains 0, okay? Okay, so you can see it here, when n is a 1 upon n, so x is a 1 upon n, so n get cancelled, it remain 1 here, so 1 minus 1, it is a 0, when we apply limit n tends to infinity to 0, it is a 0, okay? So you can see it here, the value for endpoint 0, 1 upon n, our function exists and gives a finite value, but the limit of these functions are gives different values, and when it comes different values, we say that our function is not continuous, okay? So we can see it here in our option, function given is a continuous, but we got the two different value, then we are not sure about the continuity, okay? So first option is wrong. Now second option, it is uniformly convergent, but if function is not continuous, then it is not uniformly convergent. That means continuity function, it is defined for one point, and uniformly continuous function is defined for the whole interval, okay? So if one point is not uniformly continuous, then it is for interval, it is also not uniformly convergent, okay? So these two options are eliminated here. So when we apply limit n tends to infinity, fnx we get the 0, okay? For all x belongs to 0, 1, but we cannot sure about this. We got the value for 1 also, okay? 0 also and 1 also. So this option is correct, but it is not only 0, it is also 1, okay? So we are not sure about this option C, okay? And it is single selective answer, so we have to check only one option, okay? So you can see here in option number D, it gives limit n tends to infinity fnx exists for all x belongs to close 0, 1, okay? So exactly we got same in our solution. We got the value for 0 and 1, which is exist and finite in closed interval 0, 1, okay? So limit n tends to infinity fnx is a 0 and 1, okay? So option number D is correct, and remaining all these three options are wrong, okay? So I hope so you all have understood my today's lecture on real analysis, which I covered the question from CSIR net. For similar question, if you wanted to learn more question from CSIR net, some of the topics, more topics from the real analysis, you can check it my playlist also. So I hope so you all have understood. Thank you everyone. Thank you for my today's lecture.